going to walk you through solving the function f of x equals 4x squared minus 1 over x squared minus 4 as an example for the 3.5 graphing activity. So first of all, I found my vertical asymptotes by taking my denominator, setting it equal to 0, and solving. Make sure that you write your asymptotes as equations, so x equals 2 and x equals negative 2. Let's jump down to our horizontal asymptote slash slant asymptote. The degree of my numerator is equal to the degree of my denominator, so I'm going to use my leading coefficient of the top divided by the leading coefficient of the bottom, which gives me the horizontal asymptote of y equals 4. I don't have a slant asymptote because the degree of the top is not 1 more than the degree of the bottom. Okay, next let's do our y-intercept. For y-intercepts, I plug 0 in for every x in my function, and then I simplify, so I got positive 1/4. So our answer for y-intercept is the point 0, 1/4. For my x-intercepts, I set my numerator equal to 0 and solve. When I do that, I get plus minus 1/2. My final answer, I'm going to write it as points, so I get negative 1/2, 0, and 1/2, 0. Next, I need to see if my graph intersects my horizontal asymptote. So I'm going to put my function and set it equal to the horizontal asymptote, which we found to be 4. To solve, I multiply the denominator over to the right side. I wrote that in red. Distribute the 4. And then I notice that my 4x squareds cancel out, and I'm left with negative 1 equals negative 16, which is a false statement. So no, my graph does not intersect my horizontal asymptote. Now to graph, the first thing you're going to need to do is draw your x and y axis. I purposefully gave you graphs that didn't have an x and y axis on them, so you need to draw that. Maybe you want to move your x-axis down or up, depending on where your asymptotes are. That's perfectly fine. So I did that in black. The other thing I want you to do is make sure that you give me some labeling. So I could just do a 5 unit tick mark here. Forgot to put those on here. Just helps us see a little bit better on our graph. Okay, my asymptotes I went ahead and graphed. X equals 2 and negative 2, and y equals 4. So now I'm ready to see what other information I have found so far. So my x-intercepts, I know that's at negative 1/2 and positive 1/2. So I've got 2 points right here. And my y-intercept I found to be 0, 1/4. So that's going to be right here. So the piece of the graph that's in this channel, I kind of have already found. It's going to be like this. So think about those asymptotes as my arrows get really close to them, but they never touch or never cross. Okay, now I need to figure out what's happening with my graph on the left side and the right side. So let's start over here on the right side. I have no clue if my graph is going to be up here or if it's going to be down here. So I kind of need to discover where it is. I'm going to do that by just plugging in values for x. So I could plug in 3, or I could plug in 4 or 5. Doesn't matter. I'm going to go with 3. So if I plug 3 into my equation, I get out 7. I automatically know that my graph is going to look like this because my graph cannot cross any of the asymptotes, which we found over here. So there's that part of my graph. Don't just assume that the rest of the graph is up here on the left side. It could be down here. So again, we're going to plug in a value for x. So I'm going to use negative 3, or I could do negative 4 or negative 5. It doesn't matter. We're going to go with negative 3. So when I plug negative 3 into my equation, I get out 7. Make sure that you draw arrows on the end of your graph and you make them really close to the asymptotes but never crossing. And that's how we graph a rational function. Remember, you're discovering the parts that you don't know. I knew this middle part because I had those 3 intercepts, but I had to discover these other 2 parts by plugging in numbers for x into my equation and seeing what I get out.